All right. Let's go ahead and get to our last view, and then we'll work with some of our stuff here in the border, or in the title block here, and then we will be all done for this week. All right. So now we've got our overall width here. We've got our height here, or our depth here. We've got a couple of dimensions that we need to bring down here. So let's go ahead and import those. So we're going to click in the model view, but not on the model, remember? Okay, we're going to come up here to model items. And now all of the stuff that we selected last time will still be in this one. So we're going to go ahead and hit our green check mark. And it's going to import all of our stuff. So here we've got a bunch of dimensions that are going to be gotten rid of. And 3 dimensions that we're going to keep. Okay, I'm not going to play the whole, like, weird which ones do we get rid of, which ones do we keep, and wait for you guys to pretend to tell me like Dora. So instead, let's go ahead and just get rid of this one, because we've got that one right over here. That's the addition of those 2. So get rid of that. This happens to be those 2, and that gives us the 3 dimensions that we've got left. Okay. So we've got these 3 dimensions. We've got our 2 inches up here. We've got our 0.5 over here. And we've got our radius of 0.125. So on this view, a couple of things that we're going to have to modify. You can see that there's no gap in between the model here, and then here and here. That's because if you look at it, this dimension is being pulled from down here, and this dimension is being pulled from kind of halfway through the model. In order to change that, to actually put those gaps in there, those gaps are necessary because it helps the end user tell where the model ends and the extension line begins. So we're going to click on the model, or on the dimension. We're going to click on the square that kind of indicates the end of that extension. Hold and drag. And we're just going to hover right over the end of the model. Now I'm going to let go. And you can see that it's created a small gap in there. That small gap is pretty much all we need to be able to indicate the difference and that space in there. It doesn't look like a whole lot in our model here, but when you're printing these up, it actually does end up being quite a big gap. Let's go ahead and do the same thing to the 0.5. All right. And there we go. So one last item that we're going to be doing is when in a lot of situations like this, when we're creating these things, you can have a dimension that you think is universal for things that look like they might be related, but you're not sure. And again, we want to remove the assumption process in these. So, for instance, what I mean is we've got this radius right here. Okay, and this radius right here is attached to the same edges that this radius and this radius are on. Likewise, this up here, this 1.25 radius for this, is attached to this one, but maybe not all 4 of those. And what does the end user know as far as that goes? We've also got our 0.375s here, 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 and here. So what the terminology that we use to identify that a dimension is indeed the same for all like locations is called typical. Okay? It's abbreviated by TYP. So we're going to click on the radius 1.125. We're going to come over here to the left-hand side. This is where all of our dimensional options are. Down towards the bottom, we've got dimension text. And you can see we've got R. That's that R right there. And then dim in carats. And that dim is what it actually indicates that it's going to use the dimension for that. So what we're going to do is we're going to click in that box. We're going to hit enter. Turn on your caps lock because all of our all of the words on all prints are always capitalized. We don't do any lowercase stuff on prints. That goes for title blocks, it goes for notes, it goes for just text that's on them, it goes for our initials when we check them. Everything is always uppercase. We do not use lowercase on these. That is drilled into your head day one back in the days of hand drafting. And now it's even easier because we have a caps lock tool and we're not doing this stuff by hand. So we're going to hit enter, turn on our caps lock, and we're just going to go TYP and point. Okay? That TYP, that's a radius of 0.125 typical, which means any location that it looks like that might be the radius, that is indeed the radius. So that will work for this one and this one. Likewise, we're going to come up here to this radius, 0.125. I'm going to click down in our dimension text, enter TYP point, period, whatever you want to say. Now this one has managed all of these. Now the next one, these 0.375s here, are actually the ones that are very important, because you don't ever know without putting in extension lines between two different holes if those holes share a center line location. They look like they might. However, because we don't have those going across there, it's not guaranteed. And again, we want to keep as much additional geometry and additional lines out of our model space as possible, because the more stuff we add in here, the more difficult it is for the end user to identify what the finished part looks like. So we're going to go ahead and let's see if we can do these all at one time. I'm going to click on that one, that one, that one, and that one. Click over in our dimension text. We're going to hit enter, TYP, period. Now you can see that we've just added a typical dimension to all four of those. Okay, it did, however, make these a little tight, so let's go ahead and grab those, pull them outside of the brackets. That way we're not overlapping any of our extension lines and the text that goes along with them. And there we go. That is a complete engineering drawing of a relatively simple part, yes, but it's a complete engineering drawing. So now let's go on to a couple of the other items here. So down here, we've got, we need to focus on the text block here. So this is our models, our space. I guess I'll go over the kind of layout of a sheet first of all. So you might be wondering what these numbers and letters are for. So the numbers and letters are for revision change location identification. So when we make changes to a drawing, it's called an engineering change. We've got three different ones. There's a request, an order, and a notice. But when we do these, we have to have a way to identify where on the sheet that change has actually taken place. That can be anything from a dimension, a hole size, a material. All of those can be engineering changes. And each one of those is going to be, they're marked with a letter. To down here, there's a revision block that you would have. That revision block would say what changed, from what to what, etc. And then it would have a number for to be able to drive back to what the engineering change was, because that's a separate document. And then it'll have the location. That location will be, say we want to change this 0.875 right here. So that would be location A3. Would be that location right there. And then we would have a marker right next to that identifying the same letter as our revision had, and that would be how we tell what was revised. Down here on the bottom right of every drawing will always be the title block. And the title blocks of the drawings are pretty unique per the company that uses them. However, they all have certain things in common. They'll all have the drawing name. They'll all have either a title or description. Those two are usually, they kind of go hand in hand. They'll have a weight, and they will have the draw by, check by information. So, zoom in a little bit here. So we've got drawn by, check by, engineering approved, manufacturing approved, quality approved. So generally speaking, we definitely always have drawn by, check by. That's the name. Typically, you'll use initials, and then the date that it was checked on. Those are, again, it's just to be able to find the information from for who made it and who checked it. Engineering approved, manufacturing approved, those are less likely to be used, but sometimes are used, and quality approval is the same thing. Comments can be anything specific about the drawing, but typically the comments field doesn't exist. From what I have seen, comments are typically done in notes up here in the actual drawing space because they are talking about a specific thing. So let's go to the right a little bit. we've got the title. And then down below that, we've got the sheet size. This is a B-size sheet. The drawing number. Now, the drawing number in this case is also the model name for the model here. I believe that will update. It's actually the sheet, the name of the drawing itself. So when you hit save on this, it'll actually change that to the name of the file that you're saving, which can be a little messy. That can get a little bit long, and we're going to go over how to fix that here in just a couple of minutes. Over here, next to that is the revision. The revision is, again, that ECN number that I was talking about, the A, B, C, D. Typically, revisions will be in alphabetic. It'll be alphabetic letters. Sometimes companies use numbers. Sometimes they use numbers for one thing, letters for another thing. It's a whole, depends on per company. Then down below that, you've got the scale 1 to 1. We have stopped using scale quite as much on drawings, specifically because it is so easy to modify the scales, and now people aren't using these as direct measurements. Because we have models, models actually properly sized, we don't use the measurements as much, or the scales as much, because nobody is sitting there trying to measure directly off the drawing. If an engineer needs to do something later on, they'll go back to the actual model and do something to that rather than trying to measure the model. Next to that, we've got weight. Weight is dependent on the material of an item. We don't have the material yet. And then we got sheet number 1 of 1. There can be times that you've got multiple sheets of drawings, and that'll go down here. Scooting over to the left. Okay, so unless otherwise specified, and then we've got a bunch of stuff right here. So these are what's called block tolerances. They're called block tolerances because they exist in the title block, and they are tolerances that are universal for the sheet. Now, what a block tolerance is, first of all, we've gone over this a little bit, how in the machining world, the manufacturing world, you've got your number that you're aiming for. Let's just say it's 3. And you put this thing on a machine, and you want this length to be 3. Well, 3 in a machining world almost doesn't exist. That's a theoretical number that we're basically just aiming for, but we know we'll never actually hit. A tolerance is the amount of give on either side of that we're allowed to be able to properly make the part. As engineers and designers, we have to look at a component, we have to look at the place that it's used, the assembly, how everything works together to decide what the proper size for this could be. So say we want that 3 inches. So 3 inches will fit inside the spot that we're trying to make it fit. 3.5, like if you go anything over 3 inches, it will not fit. It absolutely will not fit and cannot happen. All right. So in that case, we would give this part a tolerance on the low side. We would say, okay, so we're aiming for 3 inches, guys. But let's say you hit 2.985. So that's 15th thou or 0.015 short of what we're aiming for. That's okay. That can do it. You can do that. So in that case, our tolerance would be 15th thou negative. So minus 15th thou plus 0. So you can't go any over. You can go 15 thousandths short. So that's a tolerance in a nutshell. So here we've got fractional. We don't use fractions. Unless you're making an architectural drawing, do not use fractions. Always use decimals. So we've got angular, which is basically, again, plus or minus on angles. No angle is perfect. And then down below that, we've got plus 2 place decimal, 3 place decimal. So this is going back to that precision game that we learned about like back in high school science and math class. So the more decimal places you add, the more precise you want a component to be. So if we've got 2 places and 3 places, so we can say that a 2 place decimal. So say we've got this up here. This is a 0.5 inches, right? Say this was just 0.50. That's all it showed. On our 2 place decimal, we would have plus or minus 30. So 30 thou, 0.030. So that would mean that that dimension could vary from 0.470 to 0.530. And again, that's if this was just 2 decimal places. Okay, so pretend this third zero isn't here. So anything that's 2 decimal places, 30 thou up, 30 thou down. So 3 decimal places, we could modify this. We can say that, okay, well, this particular one, because it's got 3 decimal places in it, this is only 15 thou up and down, which is halving the size of our tolerance gap. So now we've got 0.485 to 0.515, and it's tightening that in. It's saying that we need this to be a more precise number. Now, you can get into like 1 and 2 thou tolerances, but they're very rare, they're very difficult to hold, and machinists will not like you if you do that. So generally speaking, a lot of the times you're going to be working with 5 to 30 in like in a machining world. And then in a hand manufacturing world, like the tractor trailer industry, for instance, you're going to be working with like a 1/4 inch, a 1/2 inch, much bigger tolerances. But that's what those block tolerances are. Moving down from there, interpret geometric tolerancing per. Now this is going to be a standard. Typically, it's going to be ANSI. I don't know the exact ANSI standard number, but that's what that could be. Down from there is our material callout. That'll be pulled from the model. Finish callout, we don't do a whole lot with that. Usually we're going to call out finishes, surface finishes based on the surface itself. Okay, and then applications, nobody really, that's very dangerous to put down there in the title block, and I don't think SolidWorks should have that in there. Okay, so we've got all of that explained. Let's go ahead and we'll end this one and we'll go into the next video. You can follow along while we modify some of these different features down here in the title block.